Good morning, everyone. How are you doing? Thank you for joining us here for our Beyond VMware webinar. Um, as you all know, we've all experienced sort of the ups and downs of the Broadcom acquisition, and it's presented us with a number of challenges, so to speak, but also a number of opportunities for what's next. And that's kind of what we want to talk to you about today, and in the three series to follow after this. So basically what we're going to do is we're going to go through a brief history of VMware and how we've got to where we are today, and then what that new market opportunity looks like for us, including Hyper-V solutions and a number of KVM options that are out there for you should you wish to move away from VMware. What we'll do is we'll compare those features side by side. We've got some high-level pricing to show you sort of how far the VMware pricing has increased over the competitors. And then we'll lead into the other three webinars where we're going to deep dive into a number of solutions, provide you guys with demos and also a Q&A at the end. But what I would say is if you've got any questions along the way that you think are relevant to what's being shown on the screen, please just pop them in the chat and we will answer them as we go. But yeah, thank you again for joining. I'm going to pass you over to AC, who's our principal consultant, and he's going to kick us off.
Hello, guys. I'll start with setting the landscape of a brief history of VMware. I got certified in VMware version 3 a very long time ago, back in 2006. So that's kind of where I'll start the journey. I'll probably start it there because for me, that was a junction within the industry where there was a lot of conversions going on from physical estate to virtual estate. P to V was all the buzz, and companies were getting rid of racks and racks and racks of equipment and shrinking them down to, a few or more, maybe more servers, condensing everything down. VMware was at the time very stable, fairly new, but very stable platform that people were adopting fast. It gained traction really quickly. Governments were, I don't know whether you remember, they were giving tax incentives at the time to get in because it's kind of green tech, reducing carbon, all that kind of stuff. And the industry was basically booming. VMware had a really stable platform and a really stable and successful community. I used to go to those VMUG events and it was dead exciting. So we had back then, going forwards, probably for the next 14 years, well, a little bit longer than that, we had a lot of stability. During that period, before a certain acquisition, which we'll get onto later, a milestone happened, and there's a reason. There'll be a reason for this milestone, which will kind of show itself as the slides go on. Tanzu was released. The first initial release of Tanzu released in 2020. It's mentioning that because you may have come across containers. I think everyone's at least seen a container app by now. Gartner have estimated by the end of last year, in 2025, 95% of new digital platforms will be on cloud native platforms. So containers are here to stay. Containers are here to be a modern way to deploy things. And Tanzu was Broadcom's answer, or VMware at the time's answer, to integrate containers into a VMware platform. Moving on, so more stability up until around this time, November 2023. Broadcom announced its acquisition of VMware and announced some radical changes. So there's a cut in perpetual licensing and a move to the subscription model. Significant price increases were screamed at by various people across the industry, anywhere from 50 to 800%. I had a customer come to me yesterday saying, "Oh, 400%, I can't afford it." Frightening increases. They announced they were going to shrink the product set down to a smaller number. They started talking about VCF and a thing called VVF becoming the mainstream. And yeah, so it was a sort of unstable time for everyone, I'm sure, and that's probably why you're on this call. The partner ecosystem was interesting as well. Us being a partner, everyone got kicked off it, and then it was invite only for a while, and then eventually they kind of brought it back after lots of turbulent times. So it wasn't a straightforward process for partners or customers at this time. Moving on, 2024 in June, I see as a pinnacle kind of release. The main reason why is because that is the last release where features that are in the new version 9, so if you go get VVF or VCF, the features that are in that product are not ever going to be introduced into 8.0 update 3. So it's kind of the last legacy release of the old school VMware platform. And no more will you get the new stuff. Essentially, you have to upgrade to the new iteration of the product. And then 2026 today, we're finding renewals are being blocked entirely for Standard and Enterprise Plus, or if they're being permitted, they're being capped to a short duration. VVF and VCF, so vSphere Foundation and Cloud Foundation, are essentially becoming the only way to move forward. Enterprise Plus, Standard are going to go. Those will be the only two products, and we wouldn't be surprised seeing the industry if VVF disappears and VCF becomes the only way. That's yet to be seen, but that's probably the expectation. Essentially, Broadcom are creating an enterprise-only market. They're only interested in large enterprises, and everyone else is gone. If you can afford VVF, then you do get a full VMware stack. It's probably half the price of VCF. You don't get NSX, and you don't get a full Tanzu containerization platform. You get a limited one. The reason why it's limited is because new product sets from VMware, for example, VCF automation, are containerized. And welcome to Gartner's prediction. It wouldn't surprise me if vCenter, NSX all becomes containerized and Tanzu becomes integrated into the core product set to such an extent that when you deploy ESX, it's actually a Kubernetes node and all of the bits on top are containerized. That's probably the future. It's the future of certain products we'll talk about in a bit.
There's been some changes with NSX as well, hasn't there, AC, I think?
Yeah, NSX, they have decided that they will make microsegmentation an add-on. So if you go and deploy you go and spend all that money on VCF and spend your hard-earned dollars or pounds and deploy VCF with NSX. NSX will not allow you to do microsegmentation policies. That is now an add-on license. So for those customers that have invested significantly in creating those MSeg policies and worked a lot at creating tags and doing all the things you do, it's going to break unless you buy, I believe, I haven't checked it, but I believe it's vDefend you need to buy in order to get access to microsegmentation. So again, tightening the buckle. They're slowly moving things out the core product of even VCF and putting it in add-ons. So that big number to just get VCF does not give you the whole thing. For example, you don't get AVI. You don't get the AVI load balancer. That's a very expensive add-on. So interesting landscape. As I say, probably the trajectory is just pure enterprise, very, very, very large enterprises. So what has this done? This has created a huge market opportunity. And Broadcom have forced that, for example, Microsoft, as you may know, sort of retracted Hyper-V and then went back on it and now started developing Hyper-V again and have said that, there are sort of two forks in the road for Microsoft. There's the traditional Hyper-V and then there's Azure Local. And those are the two pathways that now are there because of Broadcom. I think Microsoft would have just gone down the Azure Local had Broadcom have not done what they've done. So we're here to help, and we have deployed these products in production, and we've also deployed them in complex lab environments and done really hard road testing on them. So the subsequent webinars that follow this will be deep diving with actually showing you the product. You can ask questions while we're doing that, and we can go into specific things you need to see or do. We'll get onto that later. So broadly speaking, there are two camps. There's the camp of a proprietary hypervisor, which Microsoft call Hyper-V. That is back, as I say. That's not going to die. That's staying. They have developed it quite a lot in 2025. If you go and look at the what's new release notes for 2025, it's been developed really, really well. There's got a lot of new stuff in it. And then The next pathway would be KVM based, of which we have selected 3. There is a 4th, and I'll explain why we haven't selected it. So you got HP acquired a company called Morpheus, and they have a HP VM Essentials. They do have VM Enterprise as well product. It's a bit more expensive, but they essentially their sort of leading edge is their Morpheus VM Essentials because it's a direct competitor to VMware. You have Red Hat. Red Hat have a product called OpenShift or OpenShift Virtualization, and you have Proxmox, which branding wise feels a bit home labby. We've brought it in here. We run it in production ourselves, and it's pretty stable and it's pretty good. And we can go into what features it offers and the pricing later. The one that isn't on here that I know there's a customer on here that wants to see this is Nutanix. We haven't gone with Nutanix largely because it's less so less so as I say this today, but if we go back months, more proprietary lock-in. So, it's like proprietary code, proprietary hardware used to be. Third-party storage arrays are now there, but they only support Pure, and Pure is the only one, and it has to be a very large Pure box, an X or an XL, to do disaggregated HCI. If you don't have a Pure box, then you're only in a HCI model. So you've got what's called HCI tax, which means if you want to scale compute, you also have to scale storage. The Pure model only works with NVMe over TCP, so you need particular Ethernet fabric switches. You need particular NICs for network offload to do NVMe over TCP. Won't work on certain hardware. You have to buy very particular hardware. And also the new disaggregated HCI from Nutanix. It's so new, and they've sort of re-architected the previous product to an extent where they're not actually compatible with each other. So you can't migrate from one to other. So you sort of got this new pathway within Nutanix, which is forked off from the prior pathway. So it feels a bit early, and we're not in favor of this sort of lock-in aspect of Nutanix. But maybe when they open that, there are plans for other vendors to come into that storage space. Maybe we'll review it again, but it's not going to be on these slides, unfortunately.
I have just popped in the sorry, AC, in the Q&A. If there are any other deep dive sessions you want to explore that aren't on here, if you could just comment on my question, and then we could look to sort something out. Yeah,
100%. So Hyper-V, I put really, it's like tongue in cheek, just because it has this horrible I don't know why. Well, I kind of do know why. I'll explain why I think why. Hyper-V has this reputation of being sort of a sort of dirty, not very stable, not very capable hypervisor. And it has truth in its roots. So if we go back to when it was, I would say it got mainstream put into the kernel of Windows back in 2008. It wasn't particularly great. The prior iteration was in the user space, not the kernel space. So in 2008, it became a type 1 hypervisor, truly in the kernel, very performant, very good, not very feature rich, and not so great. Everyone was just comparing it to VMware at the time and going, what the hell is this thing? Why would I use this when I can get VMware? And at the time, VMware, you could get VM Essentials, and you get these kind of bundle deals for small environments. Why would you want Hyper-V? So it's kind of got this funny start. They've kind of fell over at the first hurdle. And that impression stuck in the industry, I think. So you move forward, and as each Microsoft operating system iterated, Hyper-V also iterated, because it's a type 1 hypervisor, it iterates with the kernel. So as they increase the feature set of the kernel, they also increase the feature set of Hyper-V. So it moves on, and I would say about here into June 2016 is when it became really good. They released a white paper comparing, which I could give to anyone they want to see, comparing Hyper-V's feature set and capabilities to VMware. And in many of the bits, and I'll go into a few in a bit, it outperforms or the criteria outstretches VMware. So they really did work hard on pushing the product, but the 2008 days kind of stuck. So we move on, and sorry, I've caught my son's cold. 2016, 2019, again, they're just iterations of the OS until you get to here. About 2020 in December, they decided they wanted to integrate Hyper-V with Azure. So they did that with a thing called Azure Stack, which at the time wasn't HCI per se. You could attach shells to Hyper-V hosts, and you could do an SDN. So you could have like BGP, kind of think of like NSX, like an SDN type dynamic networking environment, a software-defined networking. And they were kind of moving in this world where, hey, we want to integrate more with Azure. And that, in my experience, that was a sort of sideline offering to Hyper-V. It was the same kernel, same kind of core thing, but had additional features like this SDN and that kind of thing. Moving on, they kind of reiterated it all until about October 2025. They went through a number of different iterations, but it ultimately became the last brand, or the brand it is today, which is Azure Local, which is the ability to tie the Hyper-V kernel into Azure as a control plane. So you can go into Azure control plane and do things. Like, for example, you can enable SDN within Azure Local and create a NSG, so a microseg capable network security group in Azure and push it to your local on-premise environment. You can run, for example, the expensive AVD solution, Azure Virtual Desktop. You can run the desktops on-premise, or the session hosts, the RDS session hosts on-premise, and save all those compute costs because you're running them on your own tin in your own data center. You can also run Kubernetes, so AKS can run on Azure Local. The actual the grunty compute can run local, but be attached to the Azure control plane. So that is not the future. It is an offering. I'd say it's a fork. You've got two forks in the road. You've got the 2025, today as we see, you've got 2025 traditional Hyper-V offering. If you just want to do your own thing and you don't want to be tied in, maybe you're with Google, you don't trust public cloud, or you're with AWS or whatever, you wouldn't do Azure Local. If you're baked into the Azure world, maybe you'll do Azure Local, maybe. But you have those two pathways with Hyper-V. So how does it deploy? I'm just going to go over a couple of examples. These are multi-site examples where you might want to do full DR. So you'd have a primary location with 1 or 2 nodes. It's worth knowing Hyper-V scales. So it scales up to 64 hosts per cluster. VMware does 96, so it's a little bit less. It does 8,000 virtual machines inside a cluster, which is the same as VMware. It does 240 terabytes of memory per node, which no one can afford in today's climate, but it's significant. It's 10 times more than VMware. And interestingly, for those that have complex networking and do weird things with VMs, you can attach 64 virtual NICs onto a VM. We can only do 10 in VMware. There's a whole list in this white paper of things that Hyper-V theoretically does better than VMware on paper, at least. And that's a few. So you then go and do the same thing in the secondary location, and then, well, you need to get data from one to the other. So you've got some DR. So there's a couple of options. You can use the software stack within Hyper-V. Hyper-V has a feature called VM Replica, where it automatically, when you configure it, will move VM from one, or replicate a VM from one site to another. So you have the ability to do DR at a virtual machine level. The alternative is you've got a storage array. It's a traditional storage array, block or file, and you can just replicate that. It could be sync, it could be async. You could do full metro cluster if you want to. It's all possible. Where the array does file, I wouldn't recommend it. We've done our own benchmarking, and block kicks the nuts out of file. Basically, you can run Hyper-V on CIFS. Doesn't perform very well. It's nice and convenient because you can see the files on your array, like as if they're just living there. Kind of nice and convenient to administer, but it doesn't perform well. So I'd definitely go block. The reason why I've got a thing called ODX on the storage array is, I don't know whether you know this, but one of the distinct advantages of Hyper-V is that if you have an ODX enabled array and you go into a parent, i.e. parent means host, like an ESXi host, and you copy, let's say you copy a 1 terabyte file, it will copy in seconds because it goes and redirects that copy to the array and copies the file via the array. Now, the amazing thing about ODX is that also works in guests. So if you're in a guest and you've got a database that's 1 terabyte and you copy it, it copies in seconds. I can demo that in another webinar. It's frankly insane. And it works across everything within the Hyper-V world. So you could already see the massive reduction in I/O by deploying ODX. It also has a thing similar-ish to KMS, if you can get hold of KMS keys, because many people don't get them these days with the newer ways to get Microsoft licensing. But it has the ability to automatically activate the guests off the parent, assuming the parent is data center, which it should be if you've got more than sort of 8 VMs. It also has the ability to, these are just distinct features for Hyper-V. So the links at the bottom, so these, I hope you can see my mouse pointer, these links from the host 1 to the ODX array in DC1, if they die, that doesn't mean host 1 cannot talk to the storage. So host 1 can continue to talk to the storage without any storage links. So what? It can happen. So basically what happens is the Hyper-V host goes in what's called redirected access mode, and host 1 talks to the array via host 2 or 3 or 4, whichever host it wants to use. And it does that over a special CSV network. Now, obviously, if you're going to be in that situation, you've got a problem and you're going to want to fix it. But it gets you out of a short-term problem of, let's say, for example, I don't know, someone cutting some cables or a NIC failure or multiple NIC failures in a host, but the host still been up. The I/O will redirect across the cluster and back down into the storage array for you. You just need to make sure, and I've worked with environments where people haven't thought about this, you need to make sure the CSV network, which you define through metrics, network metrics in the background, is as performant or as near as you can get it as the actual primary storage links. Because if you've got 25 gig storage links and a 1 gig CSV link, you're going to be in trouble. And I've seen that before in the field. The other thing that Hyper-V does, which is really good, is you can take an predefined by you allocation of system RAM. I know system RAM is frightening at the moment, but you can do this. You can take, let's say, 64 gig out of your 512 gig and make it read cache for the host. It significantly increases performance. So if you combine the ability to use system RAM with ODX, you've got a very performant system. It gets frighteningly fast. So that there is the traditional way to do it. The other would be HCI example. So you can deploy it with hyperconverged. So again, you'd have a couple of nodes, and you'd attach that. If there was just 2 nodes, you could directly attach them. You could use 100 gig cables because they're just cables and NICs. If there was lots of hosts, then you'd need a RDMA capable, like a Rocky RDMA capable Ethernet switch, and configure that appropriately with all the appropriate queues. Essentially, within that RDMA network and SMB3, you are shared, like you do with vSAN, you're sharing disks on the local host across that IP network to be used as a storage pool, which gets allocated to the cluster to provision virtual machines. It can be done in a number of different ways. So you can do a two-way parity, two-way mirror where you have 2 copies, so it's 50% efficiency. You need 2 nodes for that. You can do it with 3-way. You need 3 nodes. You get 33% efficiency. It also does support RAID, so you can do dual parity RAID, so kind of RAID 6 style. If you have up to 16 hosts, you can get up to 80% efficiency on that. Obviously, there's a write penalty because you've got 2 parity blocks to write, so it's not performant or as performant as mirroring. Mirroring is the way to go if you want performance, and parity is best for capacity. There are some extra special use cases for 2-node clusters. So there's a thing called nested resiliency, which is quite special. So what it'll do is it will allow you to lose in that environment you're seeing on screen. If you lost node 1, you can continue to have quorum on the storage using a nested 2-way mirror or nested mirror accelerated parity. Well, that basically it's costly, but what it means is that you've got a RAID 1 mirror on server 1 mirroring to a RAID 1 mirror on server 2. That's nested 2-way mirror. Or you can do nested mirror accelerated parity, which is essentially a RAID 5 on 1 and then a mirror of RAID 5 on node 2. Obviously, that consumes more capacity, but it allows you to lose that host and survive and keep your data up. When you come to do the second DC, you'd obviously do the same thing. And then you get options. You can do the virtual machine level replication using VM replicas, or within the software stack for HCI, you can do either sync or async storage replicas. So you can replicate the volumes between sites. So pretty capable. And as I say, if you update the perception of what Hyper-V was to what it is, it's a stable platform.
Hi, AC, we got a question. So in the chat, it says, are those RAID software defined or using hardware controllers?
So the disks have to be what's called JBOD. So they're just a bunch of disks, just an individual disk. It's then the parity is calculated in software. Yeah, it's just exactly the same as how vSAN works. Exactly the same. Hopefully that answers your question.
Thank you.
So moving on to the next pathway, which would be KVM. So what the hell is KVM? KVM is again a type 1 hypervisor built directly into the kernel. It was in development since around 2006, which is 2 years before Hyper-V and around the same time as VMware. And it entered the mainstream Linux kernel in 2007. So it's an old boy. It's been around for a while. Since its inception, it's been adopted by many companies, and I'll go into that. So 2008, Proxmox got hold of it. They had their first release. Proxmox is a management wrapper, I would say, like a convenient way to manage KVM. And that's been around since 2008, which is a long time. They offer mature commercial enterprise support, which they released in 2013. That's when they first started doing that. In 2008, Red Hat got hold of KVM and acquired the actual code and wrapped it into their Red Hat virtualization product in 2009. And then a dual sort of period between 2010 and 2012, OpenStack was developed, which is a PaaS, IaaS-based platform, which has gained significant traction. It's still around today. It's still, although Red Hat are committed to OpenShift as their way forward, they are still not. They haven't retired OpenStack. OpenStack is still an option. In 2010 to 2012, people like NASA, Rackspace, Oracle, and HP massively engaged with it and had their own PaaS services offered throughout the world. So you had significant company commercial backing, not only Red Hat, but NASA, Rackspace, Oracle, and HP were pushing OpenStack, which by implication was pushing the KVM kernel through feature and release cycle. In 2020, the first version of OpenShift was released, which is a Kubernetes front end for KVM in the background. So it allows you to orchestrate virtual machines using Kubernetes CRD. CRDs is an API object essentially within Kubernetes. So it allows developers that are into modern platforms, like Gartner were predicting, like the end of 2025, 95% of new applications will be modernized. OpenShift is a way for developers to consume both containers and virtual machines through IAC DevOps type tooling, essentially. So you can write GitOps or GitLab or whatever your preferred pipeline method is to provision complex infrastructure that includes virtual machines and containers. And that was the goal of OpenShift back in 2020. Interestingly, that was 1 year before VMware Tanzu became super popular. August 2024, HP acquired Morpheus Data, which I touched on before. So one of the KVM offerings we'll go into is is HP's product. So that's when they acquired Morpheus. Morpheus was incepted around 2010, which is around the same time OpenStack was developed. And it has tight integration with obviously HP products and other storage and networking vendors. So HP VME example. So what does HP VME look like if you deploy it? We can show with the subsequent webinars, we'll actually literally show you the product and we can demo different feature sets. So you deploy a minimum of 2 nodes. If you do 2 nodes, you have to do NFS. If you do not have an NFS array, you have to deploy 3 nodes. The reason why is because the block-based file system is GFS and it's clustered, it has a quorum model, and it has to have 3 nodes. If you use NFS, then there's a proprietary quorum model built into the NFS data store where it essentially uses the NFS data store as a witness or a queue device, a quorum device, and keeps the system running. A bit like a cluster disk on Hyper-V, if you've ever used one. How does it scale? Well, it's KVM and it's Linux. So it scales testing wise. Like this is like not home lab type geeks. This is like enterprise scale tested to 2000 nodes. There is no limit on the amount of virtual machines you can put on it. It's basically down to whatever the host can handle. And you can have 12 terabytes of memory per host. So more akin to VMware in terms of memory. But I mean, who can afford 12 terabytes per host? That's insane. Backups can go to there is a built-in backup product. So you can go and back up to S3 or a CIF share or NFS. There's a plethora of options, but the native backup product, I'm not so convinced by. It creates incremental backups of the VMs as zip files and then stores them historically in the path you've told it to store them in. And I can imagine that doesn't scale very well as you get to like 20 terabytes of VMs or whatever it is that you have in your environment. I can't imagine zip files being the great solution. So there is full integration with Veeam. So you can, it is beta at the moment, and we have it in our lab in beta, but you can do Veeam backups. So for the second site, you do the same thing. And then for replication, you're essentially at the whim of your storage array or Veeam. So you could use Veeam replicas, or you could do sync or async. HP haven't yet to ratify Metro Cluster. That's coming next year. So if you wanted to do a stretch Metro Cluster, you can do it. You can do whatever you want because HP VME, you have full access to the operating system. They don't lock it. You can do whatever you want. But if you want to be supported by HP, then you need to wait until they ratify it through their Spock tool to be able to do Metro Cluster. I haven't touched on this for Hyper-V, but I feel like I should go back. So Hyper-V has the most mature support for backup through Veeam. It has full sure backup, replicas, instant recoveries, everything. It's been around for quite a long time. So I didn't touch on it in the slide. Unfortunately, I'm just going to go back and sort of mention it. Is that Veeam has equivalent VM integration as VMware does with its feature set. With VME, it's a little bit restricted. At the moment, you can't do guest OS processing, so you can't index the virtual machines, which means it doesn't really know whether there's a SQL database or whatever in there. It's quite limited. It's kind of, you can restore the VM or you can restore files within the VM. You can't restore, I need to check the documentation, but I'm pretty sure because you haven't got guest OS indexing and it's in beta, I'm not sure you can restore like a table in a SQL database. I can test it in the lab, but it's not fully production ready yet because it's still in beta.
We've got a question, AC.
One.
So with HP VME, if we started with with NFS 2 node, can you stick with NFS as you add more nodes, or do you need to move to block?
You can stick with it. Yeah, not a problem. Yeah, perfect. Yeah, no worries. You don't have to go block. I think NFS is fine. NFS will attach in v4.1 or 4.2. So, it's a modern NFS integration, and it will scale really well. So no need to go to block. I didn't mention this on the Hyper-V slide. If you want to import virtual machines into Hyper-V, you can use native product sets. So if you have System Center Virtual Machine Manager, that can import straight from VMware. If you have Veeam, you can do an instant recovery between Hyper-V, between VMware and Hyper-V. If you have a NetApp array, you can use NetApp Shift, which will using Flex Clone technology, will dynamically convert the VHDX hard drive, the virtual hard drive, sorry, the VMDK hard drive to a VHDX Hyper-V hard drive without any storage footprint increase. And the NetApp Shift toolkit will work across all of these products I'm talking about today. So if you have a NetApp, you're in a really strong position because you don't need to double up on storage as you convert. As part of the demos, we will demo the NetApp Shift toolkit because it's frankly amazing. It's just I've gone back there because I didn't talk about it on the previous slide. So with VME, yes, you can convert using Shift, NetApp Shift, into a QCOW format. QCOW is the disk format for KVM. If you can also, with the VME product, you can just literally using the native tool do an import. Unfortunately, it will shut down the source virtual machine as it converts it, but you can convert it, and it is very easy. It's a next bash done. But you can imagine, depending on the size of that virtual machine, will depend on how much downtime there is to that virtual machine, which may or may not be acceptable for your business. Obviously, if you need a shorter downtime window, then yeah, moving to something else like Veeam would be better. VME has, similar to VMware, has this concept of a centralized virtual machine manager. They call it VMM. It's essentially vCenter. It's a virtual machine. You deploy it into the cluster as a virtual machine, and that will manage. It actually creates the cluster itself. You point it at the individual hosts that you've deployed manually through the ISO, and then it will go and create the cluster for you. It doesn't currently support multi, like VMware has the sort of SSO, seamless single sign-on, and linked mode sort of stuff. It doesn't do that. Weirdly, the reference documentation from HP says to deploy it in a third site and manage your other two sites, which I don't think is a good idea. I'd probably just deploy one at each site and have two entities. I wouldn't put it at one site because if you lost the link, you'd lose access to manage the second site, which would be very painful. Anyway, it does have that toolkit, and that is very similar to vCenter, and I can demo that later. It does also do HCI, so it requires a minimum of 3 nodes. There is no way around that one. It uses Ceph in the background. Not that you need to know that. It's all kind of supported by HP, but it's using Ceph. For whatever reason, today as I'm talking, it's limited to a single disk per host. So it's obviously not quite there yet. Ceph supports a lot more than one disk. So they're kind of bringing this in. So I'm not sure whether I'd go with a HCI solution on VME today, maybe wait a little bit. But essentially the nodes are interconnected using IP 10 gig at least, ideally 25. And similar to Hyper-V, when I talked about before, you create a storage pool which exists of the disks within the cluster. Once you've got that, you have a very similar setup where you can do 3-way mirroring. Obviously, that's going to be 33% efficiency because you've got 3 copies of your data. Or you can do erasure coding as well, but you're going to get write penalty issues. You need 3 nodes for RAID 5. I'd probably go 2-way or 3-way mirror would be the way I'd go, just to get your performance. Depends on your use case, obviously. Replicating the pools between sites. the technology supports it. HP do not. Again, that points to where they are adopting this. They're not quite there yet, but it's on the roadmap. So for now, if you want to replicate between sites, Veeam would be the way to go. It's in beta. You can kind of get where this is going. It's kind of coming. A lot of it's coming. So that's the HP solution in summary. We will be demoing that later in another webinar. The next one will be Proxmox. So I'll just quickly spin that up like that. So that's how you deploy it. So again, you can do 2-node with NFS or 3-node. It uses the same mechanism. So it's GFS if 3-node on block. If it's 2-node on NFS, slightly different mechanism. So rather than having a proprietary disk-based quorum tiebreaker, you actually deploy what's called a queue device, a quorum device, which is a virtual machine somewhere else. Now I've put a little blue box called witness. So the witness in the secondary site is actually the witness for the primary, and the witness in the primary is the witness for the secondary, if that makes sense. So the witness is in the opposing site, essentially, to keep quorum. It's very quick to deploy. Proxmox is based on Debian, but they've given you, they give you very nice ISOs, which give you a really nice, straightforward installer. You can stand this up. To do multi-site took me about 25 minutes. It's fast to stand up. It's almost identical to the other KVM solutions, so very similar to VME. The main difference being this queue device thing. Missed there we go. So if you want to replicate, you can do sync or async between the arrays. You do have full Veeam support, so you can use Veeam and use Veeam replicas and all that jazz. But natively within the product, using the arrays, you would just sync and async. The challenge there becomes that the attachment, if you think to VMware, I'm assuming you guys are all VMware savvy, and you go to a data store and you go browse data store, find the VMX file, add to inventory, and then I've sort of reattach my VM. It's what SRM, let's just say it's what SRM does or Live Recovery does in VMware's, but it does it in a kind of automated fashion. Let's say you wanted to do that manually with the sync data from primary to secondary. You would essentially have to run some command line tools to re-import the virtual machines. It's doable, but it's Linuxy command liney stuff. It's not as sexy and as simple as just right click, import, add to inventory, go. You'd have to potentially modify the XML file, which contains essentially the XML file would be similar to the VMX file to point to whatever the differences are between the two environments. But it's doable and totally done it. It works fine. It's just not as convenient as VMware. There is also an external manager, so you can have a kind of vCenter type thing, which has been hailed as the thing that's going to move us close to VMware. But honestly, I'm just going to talk brass tacks. It's pretty crap. All it is a front end dashboard, which sends you back to the manager, which runs on each location. So the big difference with Proxmox over VME is VME requires this virtual machine like vCenter. And it's very difficult to manage the hypervisors without the manager. With Proxmox, the manager component or the software that gives you a GUI to manage the environment is not dependent upon any external software. They're actually systemd traditional Linux services that run on each of the hosts, and you can connect to any host and it will give you the full cluster. So you've basically got a HTTPS service running on each of the nodes, bit like the local interface on ESXi, but it happens to be cluster aware when you connect to it. If you had a very large environment with many, many hosts, like, I don't know, 30, 40 hosts, you could put a load balancer in front of those hosts and load balance the cluster API or the cluster HTTPS, and that would just simply load balance across all the hosts. So from that point of view, it's very simple. It's very fast. Looks a bit quirky, I think, personally, but it's fast and it's really stable. Yep. That's probably it for that one. And then Proxmox also has, yet again, it has a HCI example, a little bit more developed, not quite to the upstream version of Ceph, so not quite. The technology can go further, but Proxmox have put their enterprise support wrap bundle on it and constrained what is possible. They do allow up to 12 disks. I mean, I can't quite fit 12 blobs on my presentation there, but I've put two. You essentially have an OS disk, which would be a RAID 1 array, hopefully, or you could boot from SAN. And then the disks for the storage pool in the same way it was for the VME solution. You essentially just they're JBOD disks, and you attach up to 12, so you can have a lot more. Interconnection between the hosts, again, 10 gig minimum, but you really want to go 25, and you have the same erasure coding or three-way copy of the data, exactly the same technology that's been used. Again, it's the same. If you do mirroring, it's more performant, but hurts more on capacity. Whereas erasure coding, you got that write penalty, so it's slower, but you get more capacity. So it depends on use case and need. Replicating the pools between sites, again, is not supported. So if you had an enterprise support pack from Proxmox, you wouldn't get support to do multi-site replication. Although the technology could do it, and you technically could go and do it, you could force it to do it. It's not supported, but it is definitely on the roadmap. Proxmox have acknowledged that it's on the roadmap. So if you want to do HCI replication, you're really looking at Veeam. On the note of Veeam, Veeam has the most mature integration across all of the KVM options. Has really mature integration, so it can't do instant recovery, but it can do guest OS processing. So it can index the backups to give you the ability to restore individual items within those guest OSs. So if you wanted to go down granular and say, hey, restore my deleted user from Active Directory or whatever it may be, you can do that kind of stuff. So that's pretty good. In terms of migration, we can demo this for you, and we will do. It's very, very simple. You essentially point Proxmox at, you could point it at ESX vCenter, but it's not recommended. You point it at an ESXi host. Let's call that host the host which you're going to migrate from your cluster. You could point it to all of them, but that might take a bit of time. And then it simply connects to the API, reads the virtual machines, and it's about a 4-click import, and it will just take that virtual machine and convert the VMDK disk and the VMX file into the relevant KVM format for you. Again, there is a hot option with Proxmox. The ones I've done in production, I've tended to do with the source machine shut down. But yeah, it does have a hot option. I've not got too much experience with it, but it is there, which might help for those that struggle with long downtime windows or have very critical systems. Obviously, being a consultancy company, you don't have to migrate them. You could do an application level migration, replicating SQL data. There's lots of other options.
We've got another question I see in the chat just before we go on to OpenShift.
On then, yep.
So can we stand all the hypervisors discussed today up in a virtual lab environment, i.e. hypervisor running on hypervisor, just so we can give everybody the understanding of sort of the look and the feel of the different options, or is it best to stand it up on physical tin?
Can you nest virtualization? Yeah, you can nest. So I've nested in the early days of playing with VME. I nested it. Proxmox, I know you can nest. And you definitely, you can't. I don't know whether you can nest. You can run OpenShift in VMs, but when you want to run virtual machines, it's designed for bare metal. You probably can, but I've never tried it. You'd have to enable nested virtualization in VMware and give it a go. I don't know, but I know the other two definitely you can.
Is it something we could do in our lab to see if it would work?
So we could do it in our lab. Our lab, I can explain as the slides go on. I'll explain what the next steps are. But basically, in our lab, we have 18 UCS blades, and we've built it all on bare metal. So when we come to the next webinars, we will be demoing it from bare metal. I think the question is more, what do I do in my own environment? And the answer is yes for most of them. OpenShift probably, but I haven't tested it.
Okay, thank you.
So then we come on to OpenShift. So OpenShift is a modernization platform. It's a platform that I would use should you be thinking about or currently using containerization within your enterprise estate. So if you're currently invested in Tanzu, for example, OpenShift is a good choice because OpenShift can run virtual machines and containers together on bare metal. It can run virtual machines on bare metal and containers in virtual machines like Tanzu does. But the key difference there is it can run on bare metal. So you can run very, very, very performant, fast containers right next to your virtual machines, all within the same set of tool sets to deploy, to back up, to maintain, to manage. It is a kind of cloud I think of it as a kind of modern cloud in a box sort of solution. That has unique advantages over all the other options, but it is more of a kind of, it's for a company that's going to modernize. If you're not going to touch containers ever, yes, you can do it, but it's a steep learning curve. Thankfully, Red Hat will often, I've not seen them not do this yet, so I can't promise they'll do it, but I've never seen them not do it. They will often give you free training when you purchase the product to upskill you in the differences that you need to understand between a traditional hypervisor and the KVM hypervisor, which OpenShift is managing through Kubernetes. Our demo platform is set up almost identically to what's on this slide. The only difference is on the right-hand side in the secondary location, we only have a single host. So with OpenShift, you can run it with a single node, which obviously would only be for edge use cases, or the minimum would be three nodes. It does that because it runs Kubernetes natively on bare metal, and it has a control plane quorum model where you need to maintain a majority vote. So obviously you need an odd number of hosts, and three would be the first odd number. In our platform, in our demo, which we'll demo, we're running on NetApp storage. So we're running what's called NetApp Trident and NetApp Protect, which allows full site disaster recovery with sub 5-minute recovery time, and you can do zero RTO with sync rep. We've got async rep, so I don't know what our mirror update policy is. It's probably like 5 minutes or 10 minutes or something. But essentially, you can do like a live recovery or site recovery manager type failover within a very short space of time, very quickly. And that's one of the things we'll be demoing for disaster recovery within this platform. The good thing about OpenShift is you can run it anywhere. So it can run on-prem in your data center. If you want to play with it, you can run it on your laptop. If you want to have more of a hybrid approach, you can also run it in the cloud. And you can wrap a multi-cluster management tool around all the different clusters to have one single place to manage the entire stack, no matter where it is. It runs on every single cloud. Plus it's very open. It's actually certified to run on DL360 Gen 10s or DL380 Gen 10s. Gen 10 is certified for Red Hat, the latest version of Red Hat 10. So, you know, it's pretty open on what it will run on. It scales pretty well. So it scales up to 2,000 nodes, and you can run 120,000 virtual machines per cluster, which is a lot. There's a lot more than VMware. When you come to backup, because the virtual machines are ultimately KVM virtual machines like they're on the other platform, but they have, let's call it metadata within the Kubernetes database, which you need to back up because that is the source of truth as to how. It's a bit like the VMX file in VMware, but it's a bunch of metadata inside a Kubernetes database. You back the metadata up to an S3 target, so that is the box at the bottom, and then in our world, which you could do in your world, you do a S3 to S3 mirror. So you mirror the buckets between two geographies. So you have a copy of the metadata in the second location. And then the storage array replicates the persistent data. So in this case, the VMDKs, the QCOW disks, because it's KVM. And if you had containers that had persistent storage, you'd also replicate those. They're basically persistent volumes managed through persistent volume claims, maybe all funny language if you don't know what Kubernetes is, but essentially it's persistent data. So the storage array replicates the persistent data. The backup target replicates the metadata that allows the recovery of the entire stack from primary location to secondary location should you have a disaster. It does have full integration with Veeam. So Veeam do not have a backup and recovery kind of product. They have a separate product called Kasten, if I hope I'm saying it right. And that's a very nice enterprise GUI type affair, which allows you to do snapshots, backups, offsite backups, all the things you'd expect, policy driven with labels and tags and all that kind of stuff. We're all within an application which runs within the clusters essentially. And if you had two of them, you can link the two Kasten deployments together to do DR of Kasten, because if you lose Kasten, you need Kasten to recover Kubernetes, if you see what I mean. So Kasten protects itself through a recovery mechanism as well. So you can then use Kasten to recover on the second site. If you're a NetApp customer, you wouldn't really bother with Kasten because the NetApp Trident Protect and Trident products do exactly what Kasten does, but it does it for free if you've got an app. There is a huge and extensive ecosystem with OpenShift. They have this concept called operators, which is essentially like a software catalog. It's a bit like an Azure marketplace, where you can get integrations with all kinds of stuff. So you can plug it into Electras, and you can plug it into NetApps, and you can plug it into whatever you want. It can all connect in. The OpenShift and Kubernetes have been around for quite a while. So there's a very extensive integration interoperability for many different things, from storage to networking to backup, that kind of stuff. It does also support hyperconverged, which it's like I'm copying my slides between the technologies. Obviously, it's based on the same stuff. So it's KVM under the hood, and it is Ceph under the hood. So it's the same kind of stuff, but managed through Red Hat. Red Hat's enterprise support contracts, so you can call Red Hat. And you have the same thing. This example shows two clusters with a minimum commit of 3 nodes on each site. You can attach up to 12 disks into each node for the storage pool. Interestingly, the Red Hat solution supports multiple disaster recovery options. Red Hat are slightly more ahead on the DR side, so you can completely stretch the cluster if you want to. So you can do a metro style cluster between two sites. That needs a third region as a witness, just like vSAN does. You need a witness. You can do what's called metro DR, which is full sync rep of the persistent data by those links there. But then a kind of async recovery of the metadata. So that metadata that I talked about, which is like the VMX files, that would be async recovered to the sync committed data. So your data would be 0 RPO, but the recovery time would be longer because you're actually doing a restore of the metadata, which aligns to the sync repped persistent data. Hopefully that makes sense. The other thing you can do is last one, and then I'll
sorry, mate.
That's right. Last one, then you can store. The last one is you can do regional DR, where rather than doing sync or anything, you just do async. So you have an async copy. It's what we do in our lab. You have an async copy between two locations, and you do a recovery of the data and the metadata. Obviously, that makes your RPO not 0. It would be whatever your replication timer is, 5 minutes, 10 minutes, an hour, whatever it is. And the RTO is longer because you're doing the recovery of the metadata. So it's very flexible, basically. Go, Tom.
Yeah, so we've got another question. So we've mentioned that we can use the HP DL Gen 10s for OpenShift.
Yeah.
What about the other hypervisor options? Is there a limit to the age of the underlying hardware platform, or at least a target age for underlying hardware? They're just thinking from the point of view of having hardware to allow migration from VMware to another platform, i.e. reuse older hosts to provide the migration platform to then allow you to rebuild VMware hosts.
Yeah, so because it all runs on Linux, so HP VME runs on Ubuntu 2204, which is fairly open. I'd have to check, but I'm 99% sure a Gen 10 will be fine. I don't think Gen 9 will be fine. HP have their own, you've probably seen it. I don't know whether you've seen it. They've got a Spock tool, and in the documentation, they stipulate what they support. And Gen 10 is on there as far as I understand. For Proxmox, again, it's very open. I have never seen a kind of vend because it's more of a kind of open situation, Proxmox. I've never seen a list of supported hardware beyond what Debian supports. And my God, Debian will run on almost anything. It'll run on a Gen 9, no problem. So Proxmox will be very open. OpenShift falls in line with the Red Hat support matrix of what they support, and Gen 10 is currently certified. I don't think Gen 9 definitely isn't. So yeah, you could certainly retain what was a Gen 10, like 7 years old. So you can retain older hardware on these platforms and still be supported, which is a great benefit. I don't know whether you know, but in version 9 of vSphere, just for a fun fact, they've put a hard HCL deny on the install. So unless you've got the latest silicon, maybe from Broadcom, I didn't say that, then you have to basically you have to have the latest silicon to install version 9. They've hard locked it; it won't install unless you put a weird kernel argument in the installer. So all of these platforms, all these alternatives are way more open than our counterpart, which we're moving away from. So feature matrix, I've put together a list of things that each of these platforms support. So when I say high availability, I'm really talking about clustering and the ability for your workloads to survive should a node fail or there be some sort of hardware failure. They all support it. They all support the ability to recover the virtual machines or the containers, if you're doing containers and OpenShift, to the surviving hardware. They all have similar timers on how they do that, but they're all much of a muchness. Within a period of minutes, your VMs will be rebooted and restarted. Obviously, they will crash because the running memory is gone. It's exactly the same as VMware will with vSphere HA. Metro cluster is supporting everything but VME. That's coming in 2026, which is, sorry, 2020. Yeah, 2026. I forgot what year it is. That's coming this year. It's apparently Q1 this year. They're bringing it in. Resource scheduling. By that I mean the ability to say, like DRS type stuff. This VM lives on this host, or these VMs live together or apart within our environment because you've got, for example, load balancers or clustered systems you don't want on the same physical host. All of that stuff is in all of the products. It's totally in there. Live migration, it's obvious what that means, but I'll just explain it. It's just moving a virtual machine from one host to another. That's supported on all the platforms. Moving storage between, let's say you bought a new storage array or whatever, and you needed to migrate from one to other. You can do that natively in the product, not a problem. All of them support it. Disaster recovery, all of them support it. Micro-segmentation, those that are invested in NSX today and don't want to buy the add-on for V9 and move to VCF. Microseg is obviously there in VMware. Hyper-V, yes, you can do it, but caveated, you can only do it with SDN on as your local. They're apparently going to bring it into 2025, but it's in early preview. So yeah, I'd say kind of yeah, but not quite there yet. VME 100% does it, but you have to have qualified HP hardware to do it. It goes and programs the switches, the Aruba switches, and configures microsegmentation, a bit like ICE would on Cisco. It does it for you through an API, but it's only on proprietary HP hardware that it does that. OpenShift supports it out the box. OpenShift uses vSwitch, Open vSwitch, and that supports microsegmentation, and it's programmable through some annotations which you attach to the metadata for the virtual machines. So you can stop east-west traffic out the box with no add-on. It's just native. Proxmox, it kind of has an SDN feature, but it's the segmentation side of it is more macro segmentation between what they call VNets. You can probably do it, but it's not natively accessible to a friendly kind of admin interface. And you'd be digging into the back end of the OVS switch to do it. So I'm going to say no, even though technically you could. I would say no because it's not familiar and accessible to the Proxmox admin. Native, I put in quotes application containers. Application container meaning a modern container that contains all of the run times and various bits that the application needs to run. I say make that distinction because Proxmox supports LCX containers or LXC, I can't remember, containers which are technically system containers because they do not have the runtimes in the container image. They're not really like Docker container style things. They're kind of a unique use case. So I put Proxmox off that one for that reason. Hyper-V, yes, as your local only, because you can run AKS as your Kubernetes service through the Azure control plane on Azure local. VME, yes, you can do it. It's done in virtual machines, not on bare metal. And you have to have the VME enterprise product, which is a substantial uplifting cost. So you can do it, but it's uplifting cost. OpenShift, 100%, you can do it. I will be honest here. I love OpenShift. It is an add-on. So there's OpenShift virtualization as a product, which is relatively cheap. It runs containers, but only to host the platform. If you run your own container, your own like user workload container for your application in your business, then you technically should upgrade to the next version of the product. So I've put a star on it. 100% it does it, but it's a product grading thing like VMware is, and to be fair, what Hyper-V is as well. Easy migration from VMware. Obviously, VMware is out there. Hyper-V, yeah, use System Center. You can use vendor tooling, for example, NetApp Shift and Veeam. I think I said Veeam. I'm not sure. VME, you can do Veeam. You can do the native product. Or you can use Shift or another vendor product. And OpenShift has its own toolkit. It's a very simple toolkit to integrate and do hot migrations of virtual machines. You can totally do hot migrations without downtime. It will not shut down the source VM. That's native within the toolkit. Or you can also use it if you had a NetApp, you can use NetApp Shift to it. And Proxmox, yes, it has a native, very simple native toolkit to do it. Or you could use a Veeam product. So they're all kind of in there with their features.
Brilliant.
Pricing.
So we just before we go on to that, AC, we got another question.
Well,
got a couple of questions actually. So do the hypervisors have support for vGPU to provide VMs with a GPU, i.e. NVIDIA Grid?
NVIDIA Grid, OpenShift, yes. Proxmox, I don't know. I'll have to get back to you on that.
Okay.
OpenShift 100% does. Yeah, I know Hyper-V does. VME and Proxmox, I'm unsure about. I'm pretty sure. I need to go and check it. We can make a note of who asked that question, and I'll go and validate it. I don't want to make up information on a public web. I know OpenShift does. I will go and double check the other three for you.
No problem. The other question is, do the alternatives that we're discussing, do the automated DRS style switching of VMs from host to host to ensure CPU and memory load is balanced?
Yeah, so that's the resource scheduling tick box on the third row there. They all support it, yeah.
Perfect.
Yeah, they all do that kind of stuff.
Thank you very much.
Pricing wise, get ready for a shock. No screenshots. There you go. So VMware VCF and VVF are priced per core. I'm just going to explain how I got to this slide. So 138 quid and 24 pence for VVF. So VVF would include your whole stack for V9, but it wouldn't include NSX, and it would cap you on Tanzu, and you wouldn't get what's called VCF automation to do some clever automation within VMware. You don't get that. So is it half the, it's not quite half the, but anyway, whatever the difference between 254 and 138 is, it's significantly cheaper. VCF is obviously the full daddy with limits. As we've mentioned many times, VCF, you will still be needing to buy potentially a load balancer and license microsegmentation, for example. The reason why the cost there for VME is VME is licensed per socket, so it doesn't care how many cores you have. But I've assumed it's got 128 cores. The reason why is because the top tier license you can get. So for example, OpenShift is licensed for 2 sockets up to 128 cores. So I've gone off that number to make the rest of the numbers, if you see what I mean. So for example, the bottom line of dual socket 64 core equals 128 cores. So the number of 16,296 for VCF is for 128 cores across 2 sockets, which is comparable directly to OVE, which is only £1,000 for the same, and comparable to 746 for VME, and with Enterprise Unlimited support tickets at 1,870 for Proxmox. So you can see the differences there. It's frankly insane. But there you go. They are real costs. They're not made up. I've not made them up. I've got them from the market. So there you go.
They were list prices though, correct?
Yes, list prices.
Yeah.
I've put Hyper-V is free, which isn't true. If you're Red Hat House, then obviously you're going to have to buy data center, or if you have like 5 VMs or 6 VMs, you can buy standard many times, but most people would buy data center. But I don't know that many pure Red Hat houses. So most people have some form of Microsoft and will already have data center. So that is why Hyper-V is 0. I think the costs speak for themselves, really.
Yeah, we're working on some renewals at the moment, but we've had some customers of ours that we don't actually deal with them from a VMware aspect, and their renewal this year is literally double for no reason.
Yeah.
So
just because
Broadcom,
because it's January in 2026.
Yeah.
Yeah.
So
cool. I think that slide does that one. So breakdown. So we've tried to break this down into features that you guys may want. Obviously, you'll have your own perspectives on this, but this is our perspective. So if you want to do modernization and you're committed to containers in your IP, your internal application sets, then I personally would go OpenShift. If you happen to be a big Microsoft player and you had a big Azure state and you had AKS already, then maybe Azure Local would be a route for you, because you could save money by bringing your AKS clusters on premise through Azure Local. But that aside, OpenShift would be the way to go. If you have a team of developers developing your internal software, so I'm thinking of customers that do that, whether they develop them today on public clouds or wherever they develop them, they will be used to I've put DevSecOps because that's a new kind of term. So a lot of people are saying, yeah, you got DevOps, great, but it has to be secure. So if it isn't DevSecOps, it's not really DevOps, because it's not going to work very well. So this term DevSecOps has come about as a kind of an attempt to create a new standard of secure DevOps. Again, that would be OpenShift, unless, as I said before, you happen to be a very Microsoft baked in customer that has AKS already. Perhaps you could go as your local and move your AKS clusters on-prem. Cost savings, I mean, it's obvious, they're all significantly cheaper. Product maturity, now perversely, based on the history of Hyper-V, being this kind of nasty thing, which I'm trying to break that perception. Hyper-V is very mature. It's been around for a very long time, and it gets iterated with every single OS release of Windows, which is fairly often. I would say it's a very mature product. VME, as I've touched on, I'm just trying to be brass tacks and honest and straightforward. It's not quite there yet. It needs time. HP are going to throw loads of money at it. They've already got the integration with Veeam in beta. So give it another year, two. It'd be interesting where that goes. Today, I don't consider it a mature product. OpenShift is mature. It's very stable. Definitely an option for you. And Proxmox is mature. It's been around for a very long time. 2010 was its first release. So it's a very long time. So maturity wise, you've got those three. I've said nuts and bolts hypervisor. What I mean by that is I don't think any of these solutions really are trying to, well, put it this way. I think it would be a mistake as a solution architect to try and get feature parity with VMware today. I think what the approach should be is VMware offers a plethora of 1,000 things. What are the top 10 or the most quintessential business needs from VMware that I need today? And those things often come down to things like storage vMotion, maturity, vMotion, high availability, resource scheduling, these kind of things. And I'm calling that nuts and bolts. So the kind of core of what you probably need, they all have it. They're not VMware. It's really important to be clear. They're not going to parity like for like replace VMware, but they are good enough for sure. Backup interoperability, Hyper-V is probably leading the way with OpenShift as a close second. Maybe they're together, to be honest, because OpenShift has a very extensive feature set for backups. VME is not there. It's beta for Veeam, and the native product, I wouldn't trust it in an enterprise personally. Proxmox has its own backup product, which is very good. It also has deep integration with Veeam, so that gets a tick. Ease of use, Hyper-V, easy. VME, easy. OpenShift is a new skill set. I would love to say it's easy. It's easy for me because I know how to use it, but you kind of need to retrain. The good thing is that, as I said before, I've never seen Red Hat not bundle training with an OpenShift procurement. So maybe that should be a gray tick rather than no tick. Proxmox is very, very straightforward. It's very fast as well to use. Manage wrap option. So if you wanted to, let's put it this way, if you were concerned about onboarding these technologies straight away and you wanted a safe pair of hands to manage your environment, Simplify offer a managed wrap for all of those options. We have extensive experience with all of them, and we actually run OpenShift in our private cloud offering today. So that's what we do. That's why there's a tick for private cloud offering for OpenShift, and the training thing I've explained for OpenShift.
I've got a couple of questions, AC.
Yep.
So can we, just to clarify, do we need a Windows Server OS license standard or data center to run that server? And are we saying that there is no cost for the additional VMs?
So it depends on the size of your environment. So I won't bring it up now, but I've got a tool which basically is a breakpoint for when you license a Windows operating system, you get 2 virtual machines as part of that OSE operating system environment. And then imagine you've got a cluster of 2, and you bought 2 of them, so you've got 4. But if you put a VM on one, you have to also license it on the other. So you have to license that VM twice for each hypervisor. So as you build that up and you add more virtual machines, you get to a point where it just gets insanely expensive because you keep having to license the operating system on each hypervisor, and it just gets silly. The pricing just goes bonkers. So there's a break point, a natural break point where Windows Data Center becomes cheaper, and that's around the 8 to 9 virtual machine mark. Once you hit that mark, no matter how big your cluster is, you need to basically, you're going to spend too much money, switch to data center. Once you've bought data center, you license each host individually. So each host gets licensed, and then you can run unlimited versions of virtual machines on those hypervisors. So you can run like thousands of virtual machines on each hypervisor for in quotes free. It's sort of baked into the data center license. So hopefully that explains what I meant by that.
Thank you. And then what about monitoring, such as vRealize, ARIA, etc.?
Yeah, so Hyper-V has its system sensor stack. We can demo this. This will be part of the demos that we're going to do in future webinars. But basically, Hyper-V has 3 tool sets. It's got its native VMware manager, which is what's been around forever, and it's not really cluster aware. It's got a cluster manager, which is cluster aware. It's been around since like 2008, and it's not changed. So it's very basic. It's reliable, but it's basic. They then have System Center, which is a licensed add-on. You have to buy System Center. It is in the thousands of pounds, multiple thousands to buy it. But that gives you like a vCenter type thing and gives you some monitoring. The thing I will say with Hyper-V is that basically they want you to use perfmon counters and like traditional VMware things to pull data out the system to look at IOPS and things. Even System Center, it's not really that great, in my opinion, at giving you historical monitoring. It's not great. If you had something like SolarWinds or some other tool like that that could go and interrogate the back end Windows metrics and pull them into historical graphs, you're going to have a better time. VME, again, is quite limited. The virtual machine that runs the manager, the VMM manager, it's got some stuff in it, but it's not fantastic. It's fairly basic. OpenShift is good. OpenShift uses a Prometheus stack, so it has Grafana and Prometheus in the background, scraping metrics from the hosts and everything, and putting them into pretty Grafana dashboards. That out the box, it's embedded into the GUI, so it's not like you load Grafana separately or you load Prometheus separately. They present an OpenShift GUI which gives you access to those dashboards without you really knowing that it's Prometheus and Grafana behind it. But because it is Grafana and Prometheus behind it, it's very, very flexible in what you can do, and you can do long-term metrics and insanely detailed metrics and tracing and all the modern monitoring stuff. It's all in there. Proxmox, they have the manager thing, but I would say it's more of a dashboard to give you a summary of what's there. Again, it's nothing really there. It's a bit like Hyper-V. It's a bit limited. You'd be probably wanting to use another tool to interrogate the guests and the hosts to pull out long-term metrics, whether be that SolarWinds or whatever you guys may have. So I think natively out the box, OpenShift is 100% the winner, and the other 3 require third-party tooling. That's a very, very long answer. Sorry.
Thanks, sir.
So what's next? So we plan to do 3 demos, and these are dates for your diary. So anybody that's already signed up to this webinar will get notified of the next ones. You'll get an invite for the next ones. Essentially, what we're going to do is demo a summary of how to manage the platform. So how do you manage Hyper-V? How do you manage VME? How do you manage Proxmox? And how do you manage OpenShift? How do you navigate it, create VMs, that sort of stuff. We're going to talk about and demo high availability. So it's actually running in it's a Cisco UCS platform. We're running the lab on. There's 18, that's not true, 16 UCS blades. And I have the ability to just turn blades off. So I'm going to do live demos of this host has got VMs on it, and oh look, it's dead. What happens? And you can watch what happens. Resource scheduling in terms of it preemptively placing virtual machines on the hosts that have the least amount of resource. Again, we'll demo that kind of stuff so you can see it. Storage motion, vMotion and vMotion, so moving VMs and moving storage, we're going to demo. Disaster recovery, so what happens if a site fails? How do we recover to a second site? Going to demo that. Microsegmentation we'll cover with OpenShift. And then the last one we want to cover is a migration, showing you a migration from VMware into these products. So the sessions are split into 3. I've decided to put VME and Proxmox together because they're quite similar solutions, and they probably can go in one session. So that's the next steps.
So just on the next sessions, everybody on here currently will be auto enrolled into that, but we will ping out a registration link if there's any colleagues that aren't on this that you would like to register. We do have another question, AC.
Go on. Yeah.
So is there any word on VDI currently using Horizon? Also, will VM1 monitor Hyper-V and VMs?
VDI. You can do VDI and Hyper-V for sure. The thing is with VDI, with Horizon, and with Citrix, you'd need the management planes of the Horizon platform to plug into these environments. I don't think there is currently support to orchestrate them. I suspect they're going to be coming. So you'd be in a kind of.
I was just going to chip in. Sorry. Yeah. So the Horizon and Citrix stuff, it can be done as manuals on all of the platforms at the moment. So they're manual provisioning. So they've all got support for those. You have to kind of tool some of the imaging themselves. Omnis's plans are to get OpenShift as a full platform for doing VDI as well as Hyper-V. I kind of know that off the record kind of thing, but it's just a work in progress at the moment.
Yeah. So if you think of the 3 platforms, they all have the ability to do cloning. So you'd be manually, as Dave said, you'd be essentially manually cloning. So you create if it was Hyper-V, you create a template in System Manager, System Center. You'd do your patch in, put your whatever you need on the base image, including your Horizon agent, then you'd clone that out. You'd have to manually attach those clone VMs. So it's a bit jiggery pokery. The same thing with OpenShift. OpenShift supports cloning and templating with syspreps and all the things you'd expect. So you'd be in a similar boat. You'd be basically taking a template which you've bootstrapped and then cloning it out and then attaching it. It's on the roadmap. So eventually they will integrate the control planes in. I could imagine Citrix doing it too. Again, it's a roadmap thing. What was the second half to the question? Sorry.
Will VM1 monitor Hyper-V and VMs?
Yes, VM1. So Veeam and VMware pretty much have feature parity because they've been around for so long. So Veeam with Hyper-V and Veeam with VMware are really closely linked in terms of parity. When you talk about the other 3, that there's differences there. But for Hyper-V, yeah, it's got the most mature alternative from VMware. Yeah, definitely.
Brilliant. Is there any other questions at all from the attendees? Give you a couple of minutes. We will also be sending out this recording today, and it'll be available on our website as well. And then in turn, we can also put together some tech workshops if you want some one-to-one sessions with AC, Dave, and the rest of the team. Just to really hone it on your specific environments. Just reach out to your account managers, and we can get that sorted. But yeah, ultimately, I want to say thank you for attending. I hope you found the information useful. And we'll see you all on the next demo session.
See you guys. Thank you for your time.
Cheers, everyone.